Last meeting, we started something called internal forces in beams. Just to remind you, if you have a beam, looks like this. It's very important to understand this concept. This beam is supported here by columns. Something looks like this. And this column is supported by footing. Whatever. The same here, we have a column and we have footing. This structure under the effect of external loads. This external load can be distributed load, can be concentrated load, can be concentrated moment, whatever. We have something called external loads. And you can watch these loads. You can watch yourself. You can watch the furniture around you. You can watch the weight of the building. You can watch all external load. These external loads will create internal forces. Probably we can call it straining actions. These internal forces can be axial force, shear force, and bending moment. Let me explain it in more details. If you have a member like this beam, or this column, and you have external load trying to push this member like this or like this, or trying to pull this member like this or like this. So I'm talking about axial forces. The applied force parallel to the member. Here is the x-axis. Here is the axis of the member. This force or this force parallel to this axis. Here is the axis for the member. This force or this force parallel to the axis of the member or parallel to the member. These forces will cause axial force. If the force pushing, it will be compression, which is negative. If the force pulling, it will be tension, or it will be positive. The second internal force is called shear force. For any beam, is supported by a column or a support. We have external load trying to push this beam down. And we have reaction from this support or this column, this reaction trying to push this part up. At this location, we can expect shear between the two parts. So to have shear force, your forces must be perpendicular to the member. Here is the axis of the member. This force or this reaction are perpendicular and opposite to each other. So we can expect shear. The third internal forces called bending moment. By the way, if you have a force and you have suitable distance, if you multiply this force by this distance, you can get a moment. This moment will make this beam to bend like this. So, to summarize this, we have three internal forces: axial force, shear force, and bending moment. Axial force, if you have a force parallel to the member. Shear force, if you have a force perpendicular to the member. Bending moment, if you have a force and you have distance, if you multiply both of them, you can get a moment. Guys, any question related to this topic? Any questions so far? Please keep these internal forces in your mind all the time. Okay? Right now, we have a structure like this beam. We have a beam and we need to calculate the internal forces at specific point. Like this point, for example, point D. What is the axial force at this point, at this specific point? What is the shear force value? What is the bending moment value at this specific point? So the first part in this chapter, we need to calculate the internal forces, axial, shear, and the moment at specific point. We have few steps. The first step, you have to calculate reactions. Do you remember what we learned last week? Do you remember what you did in homework number 2? To calculate reactions. The problem will not ask you to calculate reactions. The problem will ask you to determine axial force, shear force, and bending moment. However, the first step, you need to determine reactions. Second step, base an imaginary section. At the point you are looking for, we are looking for point D, go ahead and cut, make cut to the beam at the specific point. Then draw something called free body diagram. Then indicate the internal forces, normal as axial, V as shear, M as moment. And then these internal forces will be in the positive direction. And then you can apply equilibrium equations. By the way, do you remember the equilibrium equations? Equilibrium equations are three. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. So we have 4 steps. These 4 steps will help you to calculate the internal forces at specific point. We have something here, we need to assume normal and the shear and the moment in the positive direction. Positive direction, which you call sign convention, for axial force or normal force, sometimes we can call it normal, sometimes it's called axial. You need to assume your force to make tension. Keep it in your mind. The positive direction for axial force is not to right, is not to left, is not to upward or downward. No, your assumed force will cause tension to the member. For shear force, we need to assume the internal forces to make clockwise rotation. CW means clockwise rotation. This force with this force would like to rotate this member like this, clockwise rotation. This is the positive direction for internal forces as shear. For bending moment, we need to assume this moment to make this member to smile. This moment and this moment would like to bend this member and make it to smile. That makes sense? So please, when you apply, when you assume axial force, assume tension. When you assume shear force, assume direction to make this member to rotate clockwise. When you assume bending moment, assume direction to make this member to smile. Let's do an example. For the shown beam, we are looking to determine the internal normal force. By the way, one more time, normal force or axial force. Both of them the same meaning. Shear force and the bending moment in the beam at point C. We have a specific point called C. At this specific point, we need to determine axial force, shear force, and the bending moment. And the problem said assume the support A is hinge or pin, whatever, and the B is roller. How can I determine the internal forces, normal force, shear force, and the bending moment diagram at C? We will do these 3 steps. My question is, did the problem ask for reactions? Did the problem ask for reaction? No. However, the first step for this problem, we need to determine reactions. If you go back, the first step in these 4 steps, we need to determine the reaction of the beam. Let's go back to the previous week and start. This one is hinge, so we have 2 reactions, YA, XA. This one is roller, so we have 1 reaction, Y beam. That makes sense? We have 3 equilibrium equation. Summation f of x equals 0. What are the forces in x direction? Only XA. Do you have anything else? XA equals 0. Summation all forces in y equals 0. We have positive YA, we have positive YB, we have negative 10 equals 0. That makes sense? Summation moment at any point equals 0. I highly recommend to take moment at one support. So we have 2 supports, A and B. I highly recommend to take moment at support with the maximum number of reactions. So I'm going to take moment at A. I'm going to assume this clockwise direction is positive. Let's start. And I'm going to ask a question. And please pay attention. I'm taking a moment at A. So XA times 0. We don't have distance for XA. YA times 0. We don't have distance for YA. Negative, because it's counterclockwise. YB times distance what? 2 meters. The distance between B and A is 2 meters. Plus 10 times what? What is the distance between this force 10 and the point A? Remember, your force and your distance must be perpendicular. So the horizontal distance will be 4 meters. Minus, I included XA, YA, YB, and 10. Please don't forget this value. 20 kilonewton meter minus, because it's counterclockwise, opposite to your assumed positive direction. I need answer. What is the distance between this 20 and point A? What is the horizontal distance between the two positions? Any answer? What is the horizontal distance between 20 kilonewton meter and point A? Any answer? It's not good. It's not good. It's not good for Benjamin and Zach. It's not good. Your answer is very, very wrong. Your answer is still wrong. And I covered this before many times. 20 kilonewton meter is a moment. This shape is a moment. If you have a moment, does not need distance. We don't need distance. Don't need distance. We don't need distance. We don't need distance because it's a moment. It's a moment. Okay? Equal 0. This term will be cancelled. This term will be cancelled. The only unknown here is YB. So I can figure out the value of YB. Just a second to grab my calculator. This value will be 20, I think. 40 divided 2, it will be 20 kilonewton. If you put here YB equal 20, the only unknown in this equation is YA. So I can figure out the value of YA. It will be negative 20. I'm sorry, negative 10. What is the meaning of negative? YA equal negative 10 kilonewton. What is the meaning of negative? No, wait. I have a wrong here. This value is not 20. Wait. Yeah. 40 minus 20 divided 2. This value is 10 kilonewton. If you put YB equal 10, YA will be 0. Okay, that makes sense. YA equals 0. Okay. So the first step in your problem, you have to calculate reactions. And believe me, if your reactions are wrong, everything will be wrong. Next step, we need to pass a section, imaginary section, to cut the beam at the specific point. We need to cut, I will cut this beam at point C. The question is, why point C? Why did you cut the beam at point C? Because I'm looking to determine the internal forces at point C. The problem said this. So the next step, or the second step after reaction, you need to cut the beam at the given point. After you did this cut, we have two options. The first option to work with the left part of the beam, this part, or the option to work with the right part. Both of them are the same. Both of them the same values, will give you the same values. So what do you think? The right part or the left part? For me, I'm gonna use the right part. Here is the right part. At this location, we have point C and you have your cut. At this specific point, B, we have reaction YB, how much? 10 kilonewton. At this free end, we have concentrated load given, how much? 10 kilonewton. Probably, or someone will say, no, I'm gonna use the left part. Okay, if you are using the left part, here is the cut at point C. At this location, point A, we have vertical reaction YA 0, we have horizontal reaction XA 0, and at this free end, we have concentrated moment 20 kilonewton meter. This one or this one. Both of them, believe me, both of them will give you the same answer. So guys, the first step, you need to calculate reaction. The second step, at the given point, we need to do cut. Then I'm gonna use probably the right part of the beam or the left part of the beam. It's up to you. One of them is enough. So I decided to use the right part. Any questions so far? Any questions so far? Okay. At the cut point, we have normal parallel to the beam. We have shear perpendicular to the beam, and we have moment. The question is, how can I assume this direction? I will assume this axial force or this horizontal force like this. Do you know why? Anybody know why I assumed the axial force like this? Because this direction related to the drawn part of the beam is tension. Does that make sense? Do you remember the sign convention? You need to assume axial force to make tension. To make tension. So this direction will cause tension to this beam. So I assumed it to left. I'm gonna assume shear like this. Why? Because this direction of the shear will cause clockwise rotation of this beam. Do you remember that? The positive direction for shear, you need to assume it to make clockwise rotation. How can I assume the moment? The assumed moment will be like this. Why? Because this assumption, which is like this, will cause this beam to smile. So I assumed the positive direction of axial force to be tension, the positive direction for shear to make this beam to rotate clockwise, and I assumed the direction of moment to make this beam to smile. Any question so far? Finally, we have normal at C, shear at C, and the moment at C. Go ahead and apply the equilibrium equation one more time. Summation f of x equals 0. What are the forces in x direction? We have negative NC. What else in x direction for this part of the beam only? Do you have anything else in x direction except NC? No. That means NC equals 0. Summation f of y equals 0. What are the forces in y direction? We have positive VC. We have positive 10 kilonewton. We have negative 10 kilonewton. Anything else in y direction? No. So this one will cancel this one. You are lucky. VC equals 0. The third equilibrium equation, summation moment at any point equals 0. I'm gonna take moment at any point, but I highly recommend to take moment at the cut, point C, equals 0. And I'm gonna assume clockwise direction is positive. Remind me, if you are taking a moment at C, please don't do the same mistake. If you are taking a moment at C, NC times 0, VC times 0, MC times what? What is the distance for MC? I'm taking a moment at this point. So NC, we don't have distance. VC, we don't have distance. What about MC? What about MC? Do you think MC will need distance? Thank you. NC is a force, still need distance. We don't have. VC is a force, still need distance. We don't have. MC is a moment, does not need distance. What else? Negative 10, this 10 time this horizontal distance equal 1 meter, time 1. And we have another 10 times the total distance plus 10 times the horizontal distance will be 3, equals 0. This term will be cancelled, this one will be cancelled. The only unknown in this equation is MC. Your value will be negative 20 kilonewton meter. So guys, finally, I concluded that at point C, we have normal equals 0. At point C, we have shear equals 0. At point C, we have moment equal 20 kilonewton meter. I am done. I am done. So, what we are covering today, we are covering to calculate the internal forces at one specific point inside the building. We have few steps. First step, we need to calculate reaction. Second step, we need to make cut. Third step, we need to draw free body diagram. Meaning of free body diagram is this one. This part is called free body diagram. Free body diagram. Then you need to assume the normal shear moment, N, V, and M, in the positive direction. For normal, to make tension. For shear, to make rotation clockwise. For moment, to make the member to smile. Then, finally, you need to apply the equilibrium equation one more time to get your internal forces. One more example. One more example. But do you have any questions so far? If you have any question, let me know. Okay. One more example. We have a beam or frame or whatever the structure. We need to determine the internal axial force, shear force, bending moment at point C in the shown beam. Do you remember what is the first step? To determine these internal forces at this specific point, first step, we need to calculate reactions. Any idea? Any idea about this structure before starting the reactions? How many reactions do you have at A? A is pin support. So how many reactions at A? Any idea? How many reactions at A? How many reactions at B or at C? Any idea? Okay, 2 at A. Any other idea for this problem? I need to listen. Any other idea? Anybody thinking about something related to this structure? Because if you cannot figure out this idea, you cannot calculate for reactions.
Probably make one reaction.
Why? Why?
Because then you can use cosine and sine.
Why? This is my question. Why? Why only one reaction? Guys, if you go back to, it's not last week, last meeting, we have a member called two force member. If you go back to our previous meeting, we have a specific member. This member is special. Do you remember we need to figure out two conditions? If the member satisfies the two conditions, I can call it two force member. We have pin connection at this end and the pin connection and at the other end. We don't have direct external load. Do you have any loads applied to this member directly? No. So this member is special. This member can be called two force member or link member. Okay, what is the benefit? What will happen if you have this member? What will happen? Like you said, at point B, we have only one reaction, or in the same direction of this member. But please make sure this member is two force member. Make sure that this member is two force member first. And then point A, it's a hinge supports. We have two reaction, XA and YA. And also we have uniform distributed load. We have two tasks here. The first task, we need equivalent here. How much this equivalent for this distributed load? Do you know? How much this equivalent? And where? Where at mid distance. So this distance will be 3 meters and this distance will be 3 meters. How much? How much is this equivalent force? It will be 5 times 6, 30 kilonewton. 30 kilonewton. One more thing. This inclined force with angle 45 degree here. Because if you draw Z shape, this angle equal 45 degree. So we will have vertical component, how much? R sine. And horizontal component, how much? R cosine. Go ahead and apply the equilibrium equation to figure out these reactions. Okay, summation. Forces in x direction equal 0. What do you have in x? We have xa, positive xa. We have positive r cosine 45 degree. Anything else in x direction? No. We have two unknowns. Summation f of y equals 0. What do you have in y direction? We have positive ya. We have positive r sine 45 degree. We have negative 30 equals 0. Take moment at any point equals 0. I highly recommend to take moment at support A with the highest number of reactions at A. I'm gonna assume clockwise direction is positive. Taking a moment at A, so XA times 0, YA times 0. We don't have distance. What else? R sine 45 degree, guys. R sine 45 degree with horizontal distance. How much? 3. We have a force. We need distance. Both of them are perpendicular. Don't forget. We have another force at point B equal R cosine. Anybody can tell me what is the distance for this horizontal component? What is the distance between this horizontal component and the point A? Any answer? Any answer? Thank you. Thank you. 0. You said this one is horizontal force. And we are looking for vertical distance, because if you would like to multiply force by distance, both of them must be perpendicular. So what is the distance perpendicular to this force, which is vertical distance between this point and this point? We don't have vertical distance. We don't have vertical distance between this point and this point. What else? 30 kilonewton, which is the equivalent load, times the horizontal distance 3 equals 0. If you look to this equation, this term will be cancelled, this term will be cancelled, this term will be cancelled. The only unknown is R. I can figure out the value of R. 30 times 3. Divide 3 times sine 45. This value equal 42.42 kilonewton. So 42 times sine 45, this horizontal component will be 30, and this vertical component 30, this horizontal one will be 30 also. If you go back and put R 42.42, XA will be negative 30. And if you put R 42.42, YA will be 0. So XA equals 0. YA equals 0. XA equal negative 30. What is the meaning? That one of your reaction equal negative value. What does it mean? What is the meaning that one of your reaction equal negative? What does it mean? Any answer? Thank you. Thank you, Marcus. Yes, you assumed wrong direction. I assumed XA to right. I'm sorry, it's wrong. This reaction must be to left. Nothing will change. Everything's the same, but only the direction will be opposite. So finally, this problem became like this. Here is point B. Here is point A. We have vertical reaction equal 0. We have horizontal reaction like this equal 30. At point B, we have two components, one vertical equal 30, one horizontal equal 30. And we have uniform distributed load. Five kilonewton per meter. What we did, only the first step in this problem, figuring out the value of reactions. Please don't forget what is required in this problem. We are looking for axial force, shear force, bending moment diagram at point C. Where is point C? Is here. So guys, we have a point here called C. We need to figure out the internal forces. Anybody remember what is the next step? Do you remember what is the next step? By the way, this horizontal distance is 1.5, and this horizontal distance is 1.5, and this remaining distance equals 3 meters. Anybody remember what is the next step? Make a cut. Thank you. Make a cut. So at point C, I will do cut. We have two options. We can work with the right part inside this circle, or we can work with the left part inside this circle. It's up to you. Both of them will give you the same answer, believe me. But I will use the simplest part, the smallest part, to make my life easy. So I'm gonna use the left part. So I'm gonna use the left part, this part. Remember, I did cut here at point C. Please put your numbers. We have vertical reaction here 0, horizontal reaction here 30. We have a little bit of the distributed load. This part only. And this horizontal distance is given 1.5 meters. Guys, I am gonna assume we have normal, we have shear, and we have moment. Anybody can tell me what is the direction of the axial force, which called NC? This normal or this axial force must be tension, like this. Are you sure? Yes, I'm sure. Because your beam that you draw, that means this direction of normal will cause tension to this beam. Pulling. This direction is pulling this beam. What is the direction of shear V at C? Do you remember? We need to assume direction to make this beam to rotate clockwise. So I'm gonna assume it like this. Why? Because this beam and this direction will make this beam to rotate like this. I'm gonna assume this moment to make this member to smile like this. Because this direction, this is a beam, so this direction will make this beam to smile. So I assumed the internal forces in the positive directions. Guys, what is the equivalent load for this distributed load? How much? Remember, to make equivalent for this part only, I'm gonna multiply the original value of the distributed load 5 kilonewton by this distance only. So 5 times 1.5 equals 7.5 kilonewton. Go ahead and apply in equilibrium equation. Summation f of x equals 0. We have negative 30. We have positive NC, nothing else. NC equals 30. Summation f of y equals 0. We have 0, this reaction. We have negative 7.5. We have negative VC equals 0. So VC equals negative 7.5. I'm gonna take moment at any point equals 0. I will take moment at point C, at the cut. I'm gonna assume this counterclockwise is my positive direction. You can assume what you want. So taking a moment at C, NC times 0, VC times 0, MC times what? I'm still repeating. I'm still repeating to remind you all the time. VNC is a force need distance, but we don't have distance. VC is a force needs distance, but we don't have distance. MC is a moment, does not need distance. Okay, what else? We have positive 7.5, this equivalent force times this little distance. What is the horizontal distance here between this force and this point? Have 1.5, so 0.75 meter. What else? 0, the reaction time horizontal distance 1.5. Negative. What else? 30 times 0. We don't have vertical distance between this force and the point C. Equals 0. This term will be cancelled. This one will be cancelled. The only unknown is MC. The value of MC will be negative 5.625 kilonewton meter. So the final answer for this problem, we have internal forces. Axial force equal 30. Shear force equal negative 7.5. Bending moment equal negative 5.6 at this specific point, which called point C. So guys, what do you think? What do you think? Any question? For homework number 3, we have only 2 problems. The first one, we need to calculate reactions, and it's given A is pin, B is roller. So go ahead and calculate your reactions. The second one, we need to determine the internal normal force, which is axial force, shear force, and the bending moment at point D. So after you calculate reaction, do the cut at point D. The second problem, the same also. We need to calculate reaction. Is given support A is roller and support B is pin or hinge. After you calculate the reactions, we need to do a cut at point C. Where is point C? Is here. So do your cut. I believe the left part will be the most easy part. Only 2 problems.